Hello and welcome again. In the previous video, we mentioned that random number generators are very important for the stream ciphers. And so we will look at them a little bit now. So there are basically three types of random number generators. The first type is the true random number generators. Then we also have the pseudo-random number generators and the cryptographically secure number generators. And we'll talk about each one of them a little bit. Now, the true random number generators are those kind of generators that actually you find in physical life. For example, when you flip a coin. So flipping a coin is a true random number generator. Or, for example, radioactive decay, when you count the number of electrons that are radioactive substance is irradiating from the substance itself. So those types of things is what we call the true random number generators. And of course, one of the properties is that the output can be not reproduced. So for example, if you're flipping a coin like several times, reproducing that exact output will be very difficult. Here the word cannot means statistically speaking, it will be very hard to reproduce the output. Doesn't mean it's impossible, it's just not feasible to do it. It would be unfeasible to reproduce that output. So those are the true random number generators. And some of the things that, for example, computers do to generate numbers is what we call the seed of the generator is going to be sometimes determined by the system of the computer. For example, the noise of the computer or temperature or time in the computer. All those of things will be a true random number generators. Now, but because they are true random number generators, well, we won't talk about them that much here. Now, the other part is the pseudo-random number generators. And what that basically means is there is a mathematical formula on an algorithm to produce those numbers. They are not really random, they're pseudo-random. So what that means is they will appear random to us, but there's really some kind of mathematical formula, or you can predict exactly what's going to happen in the next step. So what they do is they're going to generate a sequence with a seed. Okay, so the seed basically is your first number. So a random number generator will generate a sequence of numbers that will appear random to us. So the first elements of that sequence we'll call let's call it S1. It will be the seed, so it will be where you start your sequence. The next number in that sequence will be some kind of mathematical function or some kind of mathematical algorithm that you apply to the previous number. So let me explain that. So for example, you start with your seed, so you have to make a choice for your seed, S1. Once you make a choice for your seed, there is some algorithm that you apply to the number S1 to produce the second number S2. That's what I mean by the function. So the function is applied to the previous number. So f of the previous number is the next number. So the next number will be S2. Now S3 will be computed from S2 and so on and so forth. So S4 will be computed from S3 and so on. So how many you want to do? Just as many as you need for your particular problem. So that will be a pseudo-random generator number, which basically is there is an algorithm or there is a formula that tell us how to generate the whole sequence. Now, the other type that I mentioned is the cryptographically secure number generators. And these are very important because not only for cryptography, we need random numbers. We need to have cryptographically secure. And what that means is that they have to be unpredictable. Now, remember we had the sequence that was going into the stream, the sequence of the S1, S2, S3, S4, and so on. That sequence should be unpredictable. Not only should appear random, a random generation of zeros and ones, and should also be unpredictable. And what that means is the following thing. Suppose I already generated a sequence, let's say, of 100 numbers. Okay, zeros and ones or numbers. Now, to compute S101, it should be unpredictable. So I should not be able to compute, it would be unfeasible to compute 101, that number in the sequence, having the information of these other ones here. So unfeasible means that computationally wise, we won't be able to compute it. So maybe it will take a very, very long time to compute as of 101 if I know these values. Now that doesn't happen with the mathematical thing here, because it's exactly what you're doing is you compute the next one, the number that you see here, for example, x4, can be computed from the previous one. In particular, it can be computed from this guy, from S3. But for cryptography, we really need things that are secure, meaning that it is unpredictable. And the reason for that is because if the attacker gets a hold on some of your randomly generated numbers, let's say, for example, Eve has this information and somehow she can compute the next one and then the next one and the next one, because remember, this sequence of numbers is what encrypts the message, then we will be in trouble, because she will have a way to decrypt all the messages. So in cryptography, actually, there's a little bit more of a requirement for the randomness of the numbers. Now, you're basically okay if you're gonna do some kind of experiments or you're gonna perform some kind of statistical study. It is okay to use pseudo-random numbers. That's fine. But for cryptography, it has to be a little bit more than that. It has to be unpredictable. So that's the basic here property of the cryptographical secure number generators. They have to be unpredictable, and that's for the reason I mentioned, because it should be very hard, or it should consume too much time to generate the next number in the sequence from the previous one, because if it's not, then an attacker could easily produce the whole sequence if he or she gets a hold on one of the numbers in that sequence. Now, what we're gonna do a little bit now is we're gonna look at some of the pseudo-random number generators, and we're gonna look at a couple of them. So the first one is a mathematical algorithm, or it's an algorithm that's gonna tell us how to compute the sequence of numbers, and as many as you want in theory. So this is an example of the pseudo-random number generator, and it's called the Middlesquare method, and it was developed in 1946 in Los Alamos from those scientists that were working on the atomic bomb, and they usually had some applications for this from this kinds of numbers. So the algorithm goes like this. So you're gonna start with a number, a 4-digit number, any number. So that's gonna be your seed, for example. That's your starting number. The second step that you're gonna have here is you're gonna square it to obtain an 8-digit number. Now, it might happen that sometimes when you square that number, it doesn't have 8 digits. In that case, you're gonna add the little zeros if you need it. So for example, if it has 7 digits, when you square it, then you just go ahead and add a 0 at the beginning of that number. And the next thing you should do is you should take the middle of 4 digits. Made a mistake there. This is 4 digits. Middle 4 digits. So you take the middle 4 digits, and that's how you're gonna generate the next number. Now, all the numbers are gonna be generated like that. You start all over again. You start with 4. We take the 4 digit, square it, take the middle 4, and just go as long as you want to generate those numbers. So for example, let's take a particular example here. Let's just start with the number 2537. Let's say this number, and this is what we call the seed. So this is gonna be S0. It's gonna be my seed. So that's where we're gonna start. So what I have to do here, according to the algorithm that we just see there, what we do is we're gonna square that number. So we just square it. Let's just square that number. So that number will be 2537 square. Okay. You can go ahead and compute that number. So just use your calculator for that, or use Java if you want to calculate that square. Now you can write down what it is. So the number I'm gonna write down here is 6436369. Okay. So how many digits do I have there? So I have 7 digits. Okay. So because I have 7 digits, then I have to add a leading 0. So I'm going to take that number, which is 7 digits. You count is 1, 2, 3, 4, 5, 6, 7 digits. I'm going to add a leading 0 to that number. So it means I'm going to consider the number as 6, 0, 4, 3, 6, 3, 6, 9. And what you're going to do is you're going to take the middle 4. One way to look at it is just delete the first 2 and the last 2. So I'm going to delete the first 2 digits and the last 2 digits. Then I have my next number in that sequence. And my next number in that sequence will be called S1. So X1 in this case will be the number that you see right here in the middle. So it will be 4363. So it will be 4363. Now you're going to repeat this process. And the way you're going to do it is you're going to start again from S1. So we already computed the S0 and the S1. We go one step more. So we're going to compute the next number. And you see what we are doing here is really applying this algorithm, the algorithm that is here, over and over and over again to generate that pseudo-random sequence there. Now, let's do one more. So let's say, for example, I want to compute S2. That would be the next number in that sequence. So what I have to do again is take the number and square it. So let's do that. Let me change here the color. So what I have to do is I have to do 4363 and I have to square it. Now if you do that 4363 squared, it's gonna give you this number. It's gonna give you 19,035,769. Okay. Now, what happens there, then what you do is you take the middle 4. Or as I mentioned before, you just go ahead and delete the first 2 digits and the last 2 digits. Whatever is in the middle is going to be your next number in the sequence. So it will be S2. S2 will be 0, 3, 5, 7, or it's just 357. Now, you continue this way, and you generate as this is going to be your S0, yes. So you continue that way until you generate as many as you like. Now it seems like a pretty good algorithm, but there is a problem with it, and the problem is in some cases, depending on the seed that you take, the algorithm is going to be stuck in one single number. It's going to be stuck. So this is another example. So we can generate the sequence like that. If you are curious about what is S3, so I'm going to write it down. Okay. Let me see. S3 will be 1274. And you can double check that that's the actual number, 1274. All right. So, and you continue like that as many times as you want. Now let's do another. Let's take another seed. So let's say another seed. Another seed. So basically what I'm going to do is I'm going to start another pseudo-random sequence. So let's say, for example, in this case, let's change the number. Let's change the seed. And the seed will be, in this case, 2041. And you apply the same algorithm. You take the number, 2041, you square it, you get an 8-digit. If you don't get an 8-digit, you add a 0 or as many zeros as you need at the beginning of the number and take the middle 4. Now, what is special about this sequence is if you actually go ahead and do it, or you make a program to do it, something weird is going to happen here. And what's going to happen is there's going to be a number that is going to repeat over and over and over again. So basically what's going to happen here, let me write it down. Okay. When you get to the number S, let me see here, it's 16, 15, 14. When you get to that number, you get 0. Okay, you can go ahead and double check that. So you have to basically do 15 computations here to get to that number. So this is 14 instead here. We square that number, take the middle 4, and then you compute the next one. Now what's gonna happen is once you get to 0, that's it, you're stuck. Because what is the algorithm? The algorithm says, take this number, square it. Well, if you square 0, you get 0. So I get a number 0, I put 0 leading zeros until I get an 8 digit. So I have 0, I add 7 zeros, I take the middle 4, but this again 0. So S15 will also be 0. X16 will also be 0, and so on and so forth. So it has this problem. The problem of this pseudonumber generator is for some seeds, this is gonna collapse to 0, and that's usually the problem with this random number generator. So this has a problem. Now the next, so that's what I'm gonna mention here, because we just have to look at some examples how you generate pseudo-random numbers. Now the next example is gonna be about congruence, and the congruence has a particular thing. Is we talked about this in class. It was the remainder of a division, and we're gonna do that in the next video. So we're gonna see how this other example of pseudo-random number generators work when we have a sequence that is generated taking the remainder every single time in some special way. So I'll see you in the next video with that example.